Welcome, stellar students. Mr. Tating here to look at interior angles in a polygon. So what we're looking at here is basically we already know that a triangle has 180 degrees. If you add up the three angles, 1, 2, 3, they add to 180, no matter what shape the triangle is in terms of angles. It could be a 90, 45, 45, and you have all these options, infinite number of options. But what about a quadrilateral? Well, many of you know that a square has 360, but any quadrilateral will also have 360. And the reason here, and I'm trying to keep this short as possible, is we can divide up the quadrilateral into two triangles. And notice these two triangles have all of their angles that line up and fit into the exterior, portion, or the interior angles of the quadrilateral. So this triangle is 180 and that triangle is 180. So combined, those would equal 360. Now we have to be careful of how we divide up these shapes into triangles. So we're going to look at a pentagon now, a five-sided figure. And the problem is with a lot of students, when they draw these triangles, they're just going to start drawing something like this. Well, the problem here is that this triangle, right, say like right here, that angle is not part of the outside or the interior angles of the pentagon. So the way that we have to make sure we draw these are so that we're making all of the triangles, let's just try this. We're making all of the triangles sit on the outside, and the way you do that is to draw them from one vertex. So for example, I can do this. Notice how these angles here all lie on the outside, and then I draw another one maybe here. So now you draw all from one vertex, and now all these angles, they fit into that pentagon. And a pentagon has three triangles, 180, 180, 180. So the pentagon is 360 plus 180, so 540. Now, if we look at this idea, it's pretty easy. We already see that you're adding a triangle each time you add a side. So if you have a triangle, that's three sides. Three sides equals 180 degrees. Four sides equals 360 degrees. Five sides equals 540 degrees. So basically we start at one triangle at 180, and each time we add a side after 3, we're adding another 180. So the quickest way, the easiest way for me to show this is just to go right to the formula here. Our formula to find the interior angles, the sum of them, what they all add to in a triangle, is by taking the number of sides minus 2 times 180. So this number of sides is 3. 3 minus 2 times 180 equals a triangle, which is 180. So four sides, and I rewrite it like this, 180 times n minus 2. Four sides, 4 minus 2 is 2, times 180 is 360. And that's your total. Again, that's your total angles, not one angle, all of the angles added together. So with that idea, let's see if I can do that. I can. Nice. What happens if we had, say, a octagon? What's their total angle? What is the sum of the angles of an octagon? So I'll write the sum of interior angles. I'll start shortcutting it here. Sum of interior angles of an octagon would be you go 8 minus 2 times 180. Pretty simple idea here. So 8 minus 2 is 6 times 180. 6 times 180. I don't have my calculator out, so I'm going to try this in my head. 0, 8, 4, so it's 1080. 1080 degrees. Okay, so that's your sum of interiors. Now, we can take this one step further, and this is an easy step. What if it's a regular octagon? Regular meaning it has all the angles are equal, all the sides are equal, which means it's equiangular. And it's equilateral. But more importantly, it's equiangular, which means if I want one side, one angle, I can just take my 1080, and I could divide that by 8 because there's 8 angles. Now if I take 1080 divided by 8, I actually need a calculator for this. I could do long division, but that would be a lot of work to find a little number. So 1080 divided by 8, 135. So that means that if we had an octagon, let me see if I can draw an octagon here. It is a stop sign. Ugh. Let's try that again. Let's try this. And this is going to be a regular octagon, so all these are supposed to be equal angles and equal sides. Not awful, not great. So remember, all of these angles add to 1080. But this angle, 135 degrees. In fact, all the angles are 135 degrees since it's regular. Okay, so I'm going to pull up a worksheet here that you have. This worksheet is maybe 2 or 3 lectures long. So 2 or 3, like I guess you'd say lectures long. So don't stress out too much about doing the other parts. I'll have another lecture where I do other parts of this. So let's go ahead and let's go here. Okay. Zoom in a little bit. Now you're going to need to do this on a separate sheet of paper because there's a lot of information going on right now. So first, it is saying that, and I want you to make sure you see this, that they are regular polygons. Each one of these is a regular polygon. Okay, so all these angles and sides and all these pictures are equal. I'll look at, say, number 3, which is the hexagon. So this is a hexagon. 6 sides. Hexagon. The sum of the interior angles. Well, the sum of the interior angles, you do, since it's 6 sides, 6 minus 2 times 180. So that would be 4 times 180. which is 2,800 minus 4. That'd be 360 times 2, so that'd be 720. So 720 degrees. So the sum of the interior angles, 720 degrees. And this one interior angle, well, since it's regular, we can just do 720 divided by 6. And 720 divided by 6, what is that? That would be 120. 120 degrees. So this is 720, but each one of these angles is 120 degrees. So with that, you should be able to do the sum and interior of 1 through 6. 7. You should do 7 and 8. And 9. You should be able to do those. So do the sum of the interior here. We'll talk about the exterior in a different video here. Thank you, and let me know if you need to talk any questions during office hours.